Okay, that's enough of that. So this lesson is on graphing. So graphing is something we'll be doing in this course, and graphing is important in Physics 30 and 20. So yeah, drawing is a very important part of physics, so let's get to it. So when drawing a graph, make sure that you're using a pencil and a ruler, just in case you make mistakes. I don't like to see pen whiteout marks, and it's just messy. You should make mistakes on graphs. You should change things. So use a pencil and a ruler. You'll be using graphing throughout your physics career, so it's important to start good habits now, and that's what we're going to focus on with this lesson. So selecting an axis. So the manipulated variable usually goes on the x-axis, and the responding variable goes on the y. But to start off Physics 20, we're just always going to be placing the time on the x-axis, and then we'll sort of get into that manipulated responding situation a little bit later. So you want to use the largest scale possible. So what I mean by that is that I hate when there's a big graph that goes, and maybe your data goes up to 100, and then you're like 50, 100, and then 50, 100, and you just use that much of the graph, right? You want to use the whole graph, so you want to make sure that you space it apart and you figure it out. So if you have a piece of graph paper, let me just grab a piece of graph paper so we can go through it. Sorry, I was not prepared with graph paper for this lesson. Okay, so we have a piece of graph paper. So what is usually good to do is count up how many boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and try to space it apart like that. So it's also important to choose a scale. So when choosing a scale, it's really important to use scales like 1, 2, 4, 5, 10, because you should be able to half it, quarter it, without using a calculator when choosing your scale. So half of 4 is 2, half of 5 is 2.5. 5 is good if there's like little mini ticks in between. But what we want to avoid is scales like 0.337, 8.2, right? What's a quarter of 8.2? Well, you might have to use a calculator to think about what's a quarter of 7, what's a quarter of 0.33, what's half of 0.33, right? Those aren't good scales to use. And you don't need to draw a mark on every line. So I'll use the graph paper that I just grabbed and go through it. So what we want to do is if you have some data, like say it goes 100, 200, 300, 400, and then this one is 5,120, 6,240, 7,810, 9,220. So that's our data there. And we'll say that this is our x, or we'll say that this is our y, and this is our x. So we go up to 400, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we want to fit about 70% of, we want to use about 70% of the graph. That's our goal. So the best way to do would just be to go up by 50s, right? So if this is 50, this is 100. I don't actually have to mark that 50. I can just mark this as 100, this is 200, this is 300, this is 400, and this is 500, right? This is how far we go, and that's using, that we use 70% of the graph. You can see I left every second line blank, so that's what I mean by you don't need to draw a mark on every single line. And this one we want to go up to 922, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can go up to 10,000, right? So if each one is 1,000, that would work. So if we tried to draw on 1,000, 2,000, 3,000 like that, they start to bunch up. So instead of doing that, what you should do is you should just make every second one 2,000, because we know every first one's 1,000. So I'll go 2,000, I'll go 4,000, I'll go 6,000, I'll go 8,000, and then I'll go 10,000, like that. And you can see it's spaced a little bit further apart and it doesn't bunch up. So those are just some tips, and we'll practice that when we do an actual graph. So when lines don't start at 0, it can waste a lot of space, like with this one. So instead, we can mark a compression, and we don't have to start at 0. So instead of doing this, if we just do a little squiggle line like that, that's a compression. And if these are the ticks going up like that, so say this is 5, 10, 15, 20, 25, 30, like that, well, we don't need to start until 25, right? So this first line is 25, and then 30, and then we can go up by 5s after that. We don't waste as much space. So just a little compression line that looks like that. So sometimes we can't do that if we're trying to find area. So sometimes with graphs, what we'll find is we want to find the area under this graph and this area right here. You can't do that with the compression line. And also, if we're trying to find intercepts where it intercepts a y, we don't want to do that either. You can do it if you're finding slope, but you have to be careful. We'll talk about how when finding slope, you have to use 2 different points. So I wouldn't want to use this as a point and this as a point, because this is in my area of compression. When choosing your first point for your slope, you have to choose something that's out of that area in compression. So this is my point 1, this is my point 2. Don't choose anything in that area of compression. So you want to use a pencil to make each dot around the circle. So you put your data point, and then you can put a little circle around it. And that just shows a little bit of error. There's always a little bit of error with our measurements. They're not perfectly spot on, and I find it's easier to draw a line of best fit once you draw those little error circles around there. Do not connect the dots. Do not go choo, 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 because that's not what we want to do. We want to draw a line of best fit, and a line of best fit is a line in the middle of the dots with as many on top as there are on the bottom, right? You want to follow the trend of the data. So you can see the data goes up like this. We have a couple on top, we have a couple below, we hit a couple like that. That's a really nice line of best fit. And then the last thing is, don't force your line to go through the origin. You can see this line, if I continued it, it doesn't go right through 0, 0. And that's okay. Your line never needs to go through 0, 0. Don't ever force it to go through it. Yeah. Okay, so if we were drawing a line of best fit for this, this is what it would look like. I don't think I can use a... Yeah, I can't use a ruler, so it's really hard for me to do this, but I want to follow the trend of the data. Just pretend I'm using a ruler. Oh man, that was really bad. I have to do this with my mouse. Oops, now I'm highlighting, I'm erasing. Erase all ink on the slide. Let's try it one more time. So I'm going to draw a line of best fit. Oh, it's a terrible line of best fit, but you get that it's following the trend, and yeah. Use a ruler. So you need to title your graph. Title the y-axis as well as the x-axis. You got to mark your units, meters, seconds, and always use the title of y versus x. So when we actually do our graph, you'll see what I mean by that. Speed versus time is a good way of describing it. Okay, so finding slope. We can use rise over run, y2 minus y1, x2 minus x1. So when finding slope, it's important that you draw a line of best fit. And you can see 2 things are kind of happening here. You can see that this data sort of goes up like this, and the rest of this data goes up like this. So if I was drawing a line of best fit with this, I would want to follow where the majority of my data goes. So these guys are kind of outliers here because they didn't study at all and they did really bad. So this is what my line of best fit roughly should look like. Again, use a ruler. So don't use data points to determine slope. So what I mean by that is I want to choose 2 points that are easy to estimate. Let's just bring these all up. So I want to use 2 points that are easy to estimate. So this is really easy to estimate because this is definitely 100 and this is 7. And so any intersection is the best one to use, but I want to use points that are very far apart. So I don't want, like this one would be easy to estimate as well, but I don't want to use it because they're not far enough apart. So if, right here, even with my line of best fit, this would be a good point to use for point number 1, and this would be point number 2 for finding our slope. This would be okay as well because it's in the middle, so this looks like 65 and 0, so that's fine, but I'm going to stick with 1 and 2 here through those intersections. What we don't want to use is we don't want to use data points. What some people will do is they'll pick this data point here and this data point here, and they'll say 1 and 2, and they'll find the slope with those 2 points. But that's not a good plan because, well, they don't even hit our line of best fit. So you have to use points that are along the line of best fit, and you make your own points. So if I'm finding slope, I'm going to use this. My y2 is 100. And we want to put our units afterwards, so it's 100% minus 1, which is 70%. And then x2 is 7. Look at our units hours, so 7 hours minus 1 hour. So I want to calculate this and always leave it, don't leave it as a fraction, always put it as a decimal. So if I was calculating this, it would be 100 minus 70 divided by 7 minus 1, and put it in brackets just like that. And what we end up getting is we get a slope of 5. So that means that your mark will increase by 5% per every hour that you study. So 5% per hour would be our slope. Okay. Units of slope, I kind of already did that already, is just, so slope is y over x. So units of slope are just going to be the units for y over the units for x. So for this one, my units for y were percent hours, so it's percent per hour, right? So if we did the y values are meters and your x values are seconds, what would your units, what is your slope units? Well, if my y value is meters and my x values are seconds, right, y over x would end up getting meters per second. If your y values are volts and your x values are cuckoos, so maybe you're finding how many cuckoos you can get from a rooster by hooking up to a battery, which is kind of messed up, but hey, we're graphing it out. So my y value is volts, so V, and my x value is cuckoos, so it'd just be volt per cuckoos. Right, that's it. So we're going to do this graph here. We're going to do our best with my lack of ability to use a ruler, but we're going to graph this out. And just follow along with me, follow along with this video, because these are all the things that I want. So first thing I want to figure out what I'm going to have on my x and my y. In physics, it's not necessarily in order. In math, it's always x and y, but we might just give our data like this, and we don't have to give it in order of x and y, but we know that time should always go down here. So we're going to put time in seconds, and then that means we're going to put distance here, and distance is going to be in meters. So when titling my graph, I want to call this d versus t, or I can call it distance versus time. It's always y versus x. That's how we have to title it. Okay. And now we want to get our scale. So our distance goes up to 84, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we have 22 boxes. So a little thing you can do is if you go 84, so how much we go up to, divided by how many boxes we have, you can see that that's about 3.8. If you round this number up to the first good number, which would be 4, 4 is a good number to use. Yeah, we can do every box is 4. But going 4, 8, 12, 16, that wastes a lot of time. So instead of every first box is 4, I'm just going to mark every second box is 8, which still makes every first box is 4. So I'll go 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, and then 88. Okay, that's all you have to do. And then we'll count up these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So it looks like it's a square. So we want to fit 8 into 22. So we get 0.36. You always want to round it up, so we'll make every box 0.5. But again, we're not going to put 0.51, 1.52. It's just a waste of time, so we'll just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you can go all the way up even though we only go to 8. That's fine, we can use that for our slope. Okay, and now we're ready to graph out. So we want to go 2 and 22. And you can see it's nice and easy for me to estimate. I know 22 is right in the middle there. 4 and 37, so here 36, so a quarter would be 37. 6 and 62. So there's 64, so 62 is halfway. And then 8 and 84. Perfect. So we can draw our error lines around there, just little circles around each one. It's easier if you're using paper and pencil like that. And we have a nice linear one, so I have to try to draw a line of best fit. Please use a ruler when doing this on your own, but I'm just going to go slow and try my best. That's a horrible line of best fit. Please use a ruler. This is really bad. I can't, yeah. So you can see my slope doesn't go through the origin. If it goes through the origin, awesome. If it doesn't go through the origin, awesome. Who cares? So now we need to pick 2 points that are easy to estimate. So this one looks pretty easy to estimate because it looks right at an intersection. So that's going to be my point number 2. And then I'm going to start down here and find a good point that's easy to estimate. I could use this one, but I'm going to use this one right here because this is a halfway point, so that's really easy to estimate as well. So I'm going to use those 2 points. So then I'm going to use y2 minus y1 over x2 minus x1. And that's how I found my slope, which is m. So y2 is 80. Put the units, which is meters. y1, so this is 8, this is 12, and this is halfway, so this is 14 meters. And then x2 is 7.5. And x1 is 1 second, so minus 1 second. Okay, so I can find my slope using my calculator. I'll go 80 minus 14 divided by 7.5 minus 1. And I get about 10 meters per second. 2 sig digs is reasonable based on the data that I have, based on the fact that I can go in between here. 2 sig digs are reasonable. When selecting sig digs for a slope, I won't ever like make you have to choose 2, you have to choose 3. Just use a reasonable amount. If I gave 10 as my answer, that's reasonable. If I gave 10.2 as my answer, that's still pretty reasonable. If I gave 10.15, well, I'm not that accurate, so I'd say 2 or 3 sig digs is usually okay. Okay, so my answer is 10 meters per second. You can see I have meters on top, seconds down below, and that's how you do it. And that's what I'll quiz you on, so that's it. Okay, so graphing practice 1A and 1C. Don't do B. It's not necessary right now. Okay.